Good morning. This is nuclear plant components. So we finished up our last lecture on pumps, and now we will move into air compressors. Similarly to pumps, whose job is to move fluid and discharge the fluid at a higher pressure, air compressors, the intent of air compressors is to provide a continuous supply of pressurized air. So you could think of it sort of like pumping air, releasing air at a higher pressure than where the air came in at. Inlet versus outlet, suction versus discharge. So there are various types of air compressors. That are used throughout power plants and industrial settings. Compressed air, which is the discharge or outlet of the air compressor, has numerous uses throughout a facility. Including the operation of equipment and portable tools. We will talk about three types of air compressors today. Similarly to pumps again, we have the reciprocating, the rotary, and the centrifugal. So the reciprocating air compressors are the most common type of compressor used today. So here we have an example of a single acting reciprocating air compressor. So as we said, similar to pumps, we have a suction or inlet valve and a outlet or discharge valve. This is the valve right here and right here. All right, so let me erase that. You notice this valve can only open this way, and this valve can only open this way, which means if the suction valve opens this way, air comes in to this clearance space, and then eventually the cylinder, the compression cylinder, and upon discharge, air exits out this valve. So like I said, this space here is called the clearance space. So during the suction stroke, the piston here, this is the piston, it starts on its downward stroke. So the piston heads downward. As it does, the air in the clearance space here, as the piston moves down, the air in the clearance space becomes under less pressure due to the expansion in the volume in the cylinder. More volume, less pressure. So eventually, the pressure is low enough that the suction valve opens. This valve right here. Which allows more air to enter the cylinder space. So that's exemplified in step B. The piston starts to move its downward stroke, and eventually the suction valves open, allowing air to enter. So now you have more air in your cylinder. So then on the compression stroke, and we'll call that the suction stroke, pressure decrease. Get that a little better. So in the suction stroke, pressure decreases in cylinder as piston moves downward, allowing the suction valve to open and more air to enter the cylinder. So that's here. You're at the bottom of the suction stroke. Then you start to head up on your compression stroke. Piston starts to move upward. As it moves upward, the pressure begins to increase in the cylinder. And at some point, that increase in pressure forces the discharge valve open. So let's say as the piston continues upward, the inlet valve closes, and at some pressure, the discharge valve opens, which allows compressed air to be delivered. So reciprocating. The piston moves in the same fashion over and over and over in the cycles. Suction stroke, it moves down, more air enters. Compression stroke, it pushes, the piston goes up, compressing the air, closing the inlet valve, forcing the outlet valve open. So rotary these compressors are compact, relatively inexpensive, and requires minimum operating attention and maintenance. They require, or they occupy, a fraction of the space of a reciprocating machine or compressor, we'll say. Of equivalent capacity. So rotary compressors are generally classified into three groups. You have your slide vane type, your lobe type, and your liquid seal ring type. So your slide vane air compressor these are the slide vanes, and the rotation in this example occurs in a clockwise manner. So as it rotates, it operates under a centrifugal force, causing these slide vanes. As you can see, if you take a look at this one, you can see the vane, which would be the gray part, is mostly in the casing. But as it rotates, the casing is longer, with the vanes being the same size. So then the vanes, by the centrifugal force, are forced outward. So the inlet air comes here and it travels inside these casings, or these cells, I should call them. And you can see the volume of these cells where the air enters is pretty large. But as it rotates, the volume becomes smaller in the cells. As you can see, volume is pretty large in these cells, but as you see here, the volume is smaller. As it rotates, the air is then forced into smaller and smaller cells by the sliding vanes, thus pressurizing the air. So let's summarize that. So we said the centrifugal force carries the sliding vanes against the cylindrical case with the vanes forming a number of individual cells. The suction port is located where the cells are the largest. As we said, the cells are pretty large here where the air enters. So as it rotates, the size of each cell is decreased. As it approaches the discharge port. Thus, compressing the air. So for a given amount of air, if you reduce the volume, then you are increasing the pressure. And that's the principle here. So the rotary lobe air compressor there are two mating lobe type rotors in the case. 1, 2. This one rotates this way, this one rotates this way. So the suction or inlet, where the air enters, is located where the space or cavity is the largest. As the lobes rotate, the cavity space is reduced. Thus, compressing the air. So it's the same principle. A given amount of air, it enters at a low pressure. The rotation of the lobes cause the volume of the cavity to decrease, which then increases the pressure on the air, and therefore you're releasing or discharging more higher air at a higher pressure. So in our pumps, we spoke about centrifugal pumps, the advantages and disadvantages of those. Similarly, we have centrifugal compressors, and it works by the same principle. So relies, change the font, relies on centrifugal force as the impeller rotates, air is thrown against the casing of the compressor. Once again, just like in the pumps, the air particles enter through the eye of the impeller. We'll call it point D here. Then the rotation causes the centrifugal force, which throws the air out against the casing. Then the air becomes compressed. It's more and more air is thrown out to the casing by the impeller blades. There can be several stages similar to centrifugal pumps. With the end result being a higher discharge pressure. So let's talk about some properties of air. So the amount of moisture that air can hold is inversely proportional to the pressure of the air. Meaning, as the pressure of the air increases, the amount of moisture the air can hold decreases. This makes sense. As you compress air, you're forcing the liquid to condense. So the air will no longer hold as much liquid. The amount of moisture that air can hold is proportional to the temperature of the air. Meaning, as the temperature of the air increases, the amount of moisture it can hold increases. However, the effects of pressure changes of compressed air is larger than the effects of temperature change of compressed air. So what we mean by this is, as air is compressed, the pressure and temperature increase. And although the increase in temperature increases the amount of water it can hold, the greater effect of the increase in pressure due to the compression decreases the amount of moisture the air can hold. So since the air can no longer hold the water, the water begins to condense. Moisture in compressed air systems can cause serious damage, including corrosion, water hammer, freeze damage, etc. So we want to avoid moisture in compressed air systems. Coolers are used to minimize the problems caused by heat and moisture in compressed air systems. So the purpose of air coolers is to remove heat generated during the compression Purpose is to remove the heat generated during the compression of the air. This decrease in temperature reduces the amount of moisture that can be held in the air. The result is drier, cooler compressed air. Drier compressed air help prevent corrosion, and cooler compressed air allows more air to be compressed for a set volume. So if a compressor is multi-stage, then there may be an intercooler. Intercoolers are usually located after first stage discharge and after, and before the second stage suction. Aftercoolers are located on the discharge of a compressor. The moisture that is removed from the air is collected in condensate traps. So these coolers are pretty much heat exchangers. You have your air inlet flowing through, your air outlet. And your cooling water inlet and outlet. So the cooling water takes the heat from the air as it passes through the heat exchanger and leaves. So it's pretty much a heat exchanger how the compressor cooler works. We'll get more into how heat exchangers work in a later part of this semester, but that's pretty much what it is. It's taking the heat from one fluid as it travels through the exchanger. So if the moisture fails to be drained, it can be carried over into the air system itself. This can cause, as we said before, water hammer, corrosion, equipment damage, and failure of equipment. So at sufficient pressures, compressed air can cause serious damage if handled incorrectly. So safety precautions should be followed closely. Small leaks or breaks in compressed air systems can cause minute particles to be blown at extremely high speeds so eye protection is required when working around compressed air systems. Compressors make an exceptional amount of noise while running. So hearing protection is also required. Pressurized air can do similar damage as pressurized water. Closed valves should be slowly cracked open. both sides should be allowed to equalize prior to opening the valve further. Systems being open for maintenance should always be depressurized before beginning work. Contaminants such as oil should be prevented from entering compressed air systems. Oil that is introduced to an air compressor can be compressed to the point where detonation can take place. So, as a quick recap, there are different types of air compressors, similarly to how pumps we reviewed in our pumps lecture, all with the intent to discharge air at a higher pressure than the inlet. Cooling systems are required in compressed air systems to remove any heat added by the compression. And the advantages of cooling the compressed air are that cool air takes less space and holds less moisture, which can reduce corrosion and other things we generally want to avoid. And we have to be aware of any of the hazards when dealing with compressed air systems to make sure we're always working safely. This will conclude our review of the air compressor lecture. Please feel free to email me if there are any questions. Have a good and safe day.